So 6.1, we learned that this root went in the bottom of the fraction as an exponent. And then in 6.2, we said, well, what can we do with that? Well, we could do things like x to the 1/2 times x to the 1/2 is x to the 1/2 plus 1/2. Hello.
Hello.
So we learned that x to the 1/2 plus x to the 1/2 is x to the 2/2, which is just x. And we did that by remembering that like x squared times x squared was x to the 4th. That's probably not the best example because you can also multiply those. But anyway, that's what we did in 6.2 was we said, okay, now that we've overcome the fact that we have these fractions exponents, even though we don't like fractions, we're going to have to deal with it anyway. We're going to do things like multiply and divide and add like terms and stuff like that. And then in 6.3, what we did was we said, what if we had two functions, f of x and g of x, and instead of just substituting a number in, we substitute a whole equation in. So we call this composition of functions. And we're going to do some more of this today and tomorrow. So we'll review that before. So you sub in a whole like expression. Which doesn't fit there, but that's what it's supposed to say. Sub in a whole expression instead of like a number. So that's what we've done in chapter 6. And in 6.4, we want to take all of that and we want to learn about inverses in a way that is a little bit more detailed than what we've done so far. So you've been using inverses all along. We've used inverses to do things like solve equations. We did it when we had quadratics and we had to take the square root of both sides. So we've used inverses a lot, but now we're going to look at them in a broader sense and look at all the different things that inverses have in common and learn from there. So there's where we've been. This is where we're going. So we're going to do inverses today and tomorrow. We're going to go over the homework Wednesday, and we're going to have a quiz on inverses. So there are some features that they have that I want you to write down. Maybe go ahead and start your note card for this section so you have something to study for Wednesday. And then we're going to start on Thursday. They're kind of like our note cards, but we're going to do a one-pager for a variety of the topics that we're going to cover. And we're going to do this linear functions one together on Thursday. You're going to do one on Friday, your distance learning day, for quadratic functions. And these will be graded. So I've got a list of things that you have to include with those. And what they are is, instead of being note cards, it's one page, and it's going to go in your notebook for next year. Or you're going to save it for college algebra if you're going on to like statistics next year. You may not need quite as much algebra for statistics. But if you're going on to college, everybody will take a college algebra course, or a course that uses college algebra. And these are going to be like quick summaries that you've done that will say, oh, I did do this. Because look, I wrote all this stuff down. It's not just a teacher saying, oh yeah. It'll be like, and then if you're with me in pre-calculus, we'll have these as a reference. And they'll just be really short, but have a lot of stuff in them. So they'll be jam-packed with good information. And they'll be a great reference for us for our end of course exam. All right, so let's look at inverses today. 6.4. Inverses and inverse functions. That's going to be our goal for today. So inverses are things that undo. Or it could be a whole function that undoes another function. So this undoes a whole function. Bless you. In our very first section in this book, we looked at just defining things like the inverse, the identity, the I lost the word. Commutative property, associative property, all those identities we did. So inverses has to do with one of them in the fact that if you multiply by, we saw this in the beginning of the year, like if you had 5 and you multiplied it by 1/5, you got 1, right? So 1 was the identity, but this is the inverse. The 1/5 undoes the 5 and then takes us back to 1. If you have 2 plus -2, you get 0. You get the identity for addition. The -2 undoes the 2. And that's what we're looking about for inverses. And we've lost our screen. Hold on. Okay, and we're back. So, inverses undo things. So what we're going to try to do with these inverse functions is we're going to try to have an x term. And if something's been done to it, like if we have f of x equals 2x plus 5, in order for us to see what we can do to undo things, okay, I'm not making any sense. Rewind on your video. Just kidding. If we look at f of x right now, two things are happening. X is multiplied by 2, and x is greater because we've added 5 to it. Or the whole value is greater because we added 5 to it. So two things are happening. Multiply by 2, add 5. The inverse function will have to undo both of those things. It will have to subtract 5 somehow and also divide by 2. It will do the opposite. Just as 1/5 undid the 5 and -2 undid the 2. So we're looking at undoing. Okay? That's the goal here with inverses. So what I want to do is first make a list of features of inverse functions. So the first one is the x values and the y values switch. And we're going to go through examples of all of these in just a second. But the x values and the y values switch. Because they've switched, the inverse function undoes the original. Oops. And the result is x. You'll see what I mean when we do some examples of that. The result is x means that it's just x. It's not 2x or x plus 2 or x plus 5. It's just plain naked x. Nothing else is happening. 3. The original graph, or the original functions graph, and the inverse functions graph reflect over y equals x. Now I'm just trying to put this in kind of a very succinct list first, and then we'll go through these examples. So we'll be able to look at the graphs and see if they're inverses or not. For inverse notation, looks like this. F inverse of x. So this is a very unfortunate duplication in my estimation, but this -1 means inverse. not 1 over f of x. This is an important distinction. If I was in charge of making notation, I wouldn't have chosen this. Maybe I would have said f and like an n up there or something. Like inverse sounds like n. Or an I, or I have no idea, but star, anything else. But somebody else chose this, and it's been this way for too long for me to change it, and I'm not, nobody's going to listen to me anyway. I guess it's like the different USB ports. They're all different, and we can't help it. So this means f inverse. So when you hear me say that, you're going to write f and then to the -1 power. You can prove two functions are inverses with composition. So we did composition before spring break, and composition means if we said f and then we put the inverse inside, we put the inverse and substituted it into the function, we would get plain naked x out, because the inverse undoes whatever's happening, then you get a plain x out. And you could do the reverse. You could say the inverse and put the function on the inside. So we'll practice that and you'll see what I mean. But there you go. Now back to the top. This is supposed to be an S and it looks terrible. What do you know about functions? In order for a function, it has to pass that vertical line test, right? Good answer. So it has to pass a vertical line test. Well, one feature for functions to have inverses is that they must be 1-to-1. And that'll be part of our discussion. Your book would write it out 1-to-1 with words, but there you go, 1-to-1. So let's talk about all of these things and let you see what they look like. So first of all, x values and the y values switch. What does that mean? I'll move this up so you can still be writing if you need to. Let's look at this. If I say, here's a list of x, y values. We're going to have 0, 6 as a point, and 1, 4 as a point, 2, 2, 3, 0, 4, -2. So this is some function, and none of the x values repeat. Do you remember in that section we did where we were talking about functions, and we made that list, and we made the arrows to make sure that we didn't have the same x value repeated twice? Well, we don't. So this is a function, and we could call this f of x. I don't know that it has an equation or anything. These are just points in my function. Sometimes functions can just be points. So I don't know if this is a line or a parabola. I have no idea. I just have these 5 points. But I do know that it's inverse, f inverse, and that pen is dead. See if this is a different color. Yes. It would be still x and y, but number 1 in our list of inverse features is that the x and the y switch. So my very first point, instead of being 0, 6, is going to be what? 6, 0. So it's just as straightforward as that. The inverse function switches the x and the y. So we could do this pretty easily. We just take any of the points that were given for the original and we switch them. So 4, 1 is a point. 2, 2 is not that exciting. 0, 3, -2, 4. So this is the number one, X and Y switch. It can't really be any easier than that. How about that? Good? Okay, so if we graph those two things, let's see what they look like. So I'm going to graph in my two colors. I've got 0, 6, 1, 2, 3, 4, 5, 6, 1, and then 4, 2, 2, 3, 0, 4, negative 2. Okay, so this kind of looks like a line. It goes down by 2 every time, so it is a line. It should be straight. Okay, so there's my green. That's my original function. And then my inverse function are just points that have been flip-flopped. So all of the x's are now y's, and all the y's are now x's. So now I have 6, 0, 4, 1, 2, 2. They go through that same point. 0, 3, negative 2, 4. So when you look at those two lines, what's cool about them, and we'll see this with more interesting graphs that as we move forward with other examples, is that if I draw the line y equals x in the middle with my pen that doesn't want to write, then you could like fold your piece of paper and this green line would match up with the blue line and this blue line would match up with the green line. It reflects over the line. This is the line y equals x, where I have slope of 1 up, 1 over 1 with a 45-degree angle, all that stuff. So this is what I mean by, and this is supposed to be a y. This is what I mean by number 3, the original function's graph and the inverse function's graph reflect over the line y equals x. So it will always be this line that cuts at a 45-degree angle where you could like fold your piece of paper and they would match up. Do you see that? Yeah? Both of these are functions. I could draw a vertical line on the green line or the blue line and I would still have a function. So this works. They are both inverse and they're both functions. So let's see another example. That is an example of just points. For whatever reason, my other Algebra 2 class really wanted to take those points and turn it into an equation of a line every time. And all I wanted them to do was switch the x and the y value. So number 1, x and y switch. Don't make it harder than it is. It's actually a very easy sort of question. Yeah? Okay. So this example, maybe put a star by it. So you're not that person. Okay, so this time we're given an equation. We want to find an equation. So example 2, I've got an equation. Y equals 3x minus 5. So this is a line. And right now, two things are happening to this line. One of the things that's happening is that x is multiplied by 3. The other thing that's happening is that that value has 5 subtracted from it. Casey, play with us. There we go. So I want to find the inverse function, the one that undoes it and makes it just plain x. So number 1 on my list, what did we do in that last example? What did we do with x and y? We switched them. So when we do an inverse function, first we switch the x and the y. So that's going to be my first step. So I just take this and I rewrite it. I'm going to write it as x equals, and then this x is going to be a y. So I switched y for x and x for y. That's it so far. Now my goal is to solve for y. So right now I have 3 times y minus 5. I need to move everything to the left-hand side. So what do I do first? Divide by 3 or move the 5? Move the 5. Excellent. So plus 5 to both sides. We get x plus 5 equals 3y. Now I don't have y by itself yet. We need to divide by 3 or multiply both sides by a third. They both work. I'm going to multiply both sides by a third just because I have this binomial over here, and I have to multiply everything by a third. So it doesn't matter. Either way, you could have also said x plus 5 equals 3y and divided by 3. That would give you an answer. Oops, wrong one. This gave me an answer like this. Or you could even say x plus 5 all divided by 3 equals y. These all mean the same thing, and I don't care which one you give me, so whichever one floats your boat is perfectly fine. But let's look at this. This is my inverse function. I probably should just add this in here. That tells everybody that this is an inverse, and we'll get used to that notation. So I want you to recognize that f to the negative 1 really means f inverse. I won't ever call it f to the negative 1. I'll say f inverse every time. So it's just a name. It doesn't actually mean do anything with the negative 1. Now, the original one had 3 times x and a minus 5. This one has the opposite. It's got a division by 3 and a 5 added, so it's the opposite. This has divided by 3 and a 5 added. They're all 3 different ways to say the same thing. Either one of these works. You don't have to tell me all 3, but any style of math that you like is fine. They're all equivalent answers. So this should undo the original. That's what an inverse does. So if I ever ask you what the goal of an inverse function is, the goal of an inverse function is to undo the other function. It's why we take the square root when something's squared. We're trying to undo the square. We're trying to undo. It's like having a shoe tied and then, your very best friend can't help it. They untie it. So what's been done is undone. None of you here would do that, I'm sure. But let's look. How we prove it, I don't remember what number that is on my other page, is we do composition. And I want you to see what that looks like here. So composition of functions means that we have this original function, which I'm going to call f of x. And I have the inverse function, which I'm gonna choose this one, x plus 5 over 3 for right now. And I have to compose one inside the other. So this is our review of section 6.3. Composition of functions says f of f inverse of x. So that notation, that's okay? Okay, so here's what we do. We're going to say f of, and instead of f inverse, I'm going to put this here, x plus 5 over 3. So instead of substituting a number and figuring something out, I'm putting in a whole equation. So this is my whole equation. I'm going to put this into f. So f says 3, and then there's an x. That's where I put stuff. But what am I putting here? So this is 3x minus 5, and I want to put the other function in it. So I want to put this function here, x plus 5 over 3. So we write out a function and we put the other one inside of it, and then we simplify, which is cool because look, the 3 on the top and the 3 in the bottom, they cancel, right? So that's gone. Now what do we have? We have x plus 5 minus 5. What's x plus 5 minus 5? I'm so close. With the plus 5 and the minus 5, so we still have the x. And this is our goal, plain naked x. What happened? We had 3 times x and a minus 5. What did we do? The inverse function stripped away all the other stuff and just gave us plain naked x. Does that make sense? You can do it the other way as well. And let's just see it because we're here. If we did it the other way, I'll put it here. F inverse of f of x. That means we're taking this function, that's the outside function, and we're putting this one inside of it. So we're really saying 3x minus 5, that's what f of x is. We're going to put it into this function this time. So I'm going to rewrite it out. It says something plus 5 all divided by 3. So I'm putting this function into x right here. I'm going to plug it in right here. 3x plus 5 goes here. Oops, it's minus 5. 3x minus 5. So I just put it right there. How does the top simplify? Because it says 3x minus 5 plus 5. It would be 3x over 3 equals x. So composition of functions, the reason we did that in the last section is so we could apply it here and prove that two functions are inverses of each other. So they undo everything. Do you get the part where they undo? And we got plain naked. Yep. Okay. So what else can we do? They've given us, they still do that. We're gonna let's see, I'm gonna pause. Okay. Sure. Okay, so a function and its inverse. We're going to look at the graphs for a second. So the graphs. So I went back and amended my list to include the one-to-one stuff. So we're going to look at this. This will be my example 3 for the day. Let's say we have something very basic like y equals x squared. Y equals x squared. You're going to have this on your Friday's one-pager where you're going to say, okay, this is a quadratic because it has a squared. It's the parent function, actually, so it starts at 0, 0. It doesn't have any shift. So my vertex is here at 0, 0, and then you can make an XY chart to remember how to do stuff. Yep. It says quad. It's a quadratic. It's a quad parent. It's a quadratic, like that's one line. And then the parent function, that's the second like name for it. And then 0, 0 would be the vertex because it's that parent function. Sure. And then the graph looks like this, where we said if you put in 1 and you square it, what do you get? 1 right here. 1 squared? 1. Negative 1 squared? 1. So we've got 1 and negative 1 give the same point. How about 2 squared? So 2 is at 4, and then negative 2 squared? 4. So we have this parabola that we remember from before, and it's round at the bottom. Remember, not pointy. It's kind of round at the bottom. If we put in 3, we get 9. That's why it curves up, because it starts going faster and faster up. And this is a function. But what if we took those points and we made it an inverse? What would its inverse be? Like we just learned on our example 1 that all we have to do is take all these points and just flip them. So 1, 1 would still be 1, 1. But this one would be 1, negative 1. The second one? Yeah. This one? 4, 2. And then 4, negative 2. Is the inverse a function? So let's graph it if we're not sure. Really want a third color. Okay, so if I graph this guy, I'm going to go to 1, 1, and then 1, negative 1. We didn't put 0 in. I could put 0, 0 in too. That's still good. So Liz already says no. How come? You're right.
No. I'm right?
Correcto.
Yeah. So if we connect these guys, is this a function? So if I draw a vertical line through the red, how many times do I touch it? It doesn't pass the vertical line test. So see how 1 gave 2 answers here and 4 gave 2 answers? So this is not a function.
Oh, this is yeah.
Does not pass the vertical line test.
Because there's 2 x's.
Yeah, so if you ask the calculator, hey, what happens at 1? It's going to say, I don't know. Do you want 1 or negative 1? Like it's confused. So if you ask a calculator and confuse it, it's not a function. So it represents like an inverse, but it's not a function. So it's not something we can put in a calculator. And so we're going to find a trick to get around that. But first, in your homework tonight, you're just going to tell me whether it's a function or not. So if you were to graph it and make a list and make its alternate list, then you can look at it then and say this does not pass the vertical line test. And you don't have to say that completely out. But you do have to have an idea of what the original function looks like. So you are going to have to go back and remember some stuff from before. And if you're not exactly sure, what do? You just make an XY chart. Right? You can make up any XY chart. You just make up X values and then plug them in and then see what you get. And then you get a sketch for the graph. So that'll help you remember some stuff. And then you'll be like, oh, that was shifted or whatever. Some of those things will come back to you. But so if the question was, is its inverse a function? Is its inverse a function? You'd say no. No. That's supposed to be a P. Vertical line test. And you can do that with an XY chart. You can do that if you know what it looks like. Or if you're given a picture, you can think of it turning sideways. Because that's basically what happens, is that all those values are switched, so they turn sideways. This does still reflect over this line. So if you were to fold it on this line, the red and the green would match up, and this red and this green would match up. So it still folds, it's just not a function anymore. And we'll get around what to do about that tomorrow. But the questions that you're asked are just, is it a function or not in the inverse? And that's what we've got for this section. So what are you going to do? You're going to do this part where you have to switch X and Y and solve for Y. And then it says verify them. You're going to have to prove with composition. And yes, you need to do both ways because you're baby inverse provers. So until you're master inverse provers, you have to do both ways. Gives you that good practice. And then you've got to check and see whether the inverse would be a function or not.